Hello Cloud Gurus, my name is Adrian, and in this lesson I'm going to discuss partitions, the underlying physical storage structure of DynamoDB. So what are partitions? At the associate level we were taught to ignore the underlying structure and consider DynamoDB a database service platform with unlimited performance and scalability. I'm not here to change that, but at the professional level we need some awareness of how things actually work under the hood, so that as DevOps professionals we can design and implement an appropriate data structure for our applications with the knowledge of how this structure will perform, its limitations, and how to overcome them via operational tweaks. Partitions, as we've discussed, are the underlying storage and processing nodes of DynamoDB. When you create a table with the default settings, DynamoDB allocates your table one underlying partition. By default, until things change, all storage requests and any compute operations such as insert, delete and update operations are handled by the node on which that partition is stored. A key element of DynamoDB is that you don't need to, nor do you have direct control over the number of partitions, but they can be influenced. A partition can store a maximum of 10 gigabytes of data, and a single partition can handle 3,000 read capacity units and 1,000 write capacity units. As you can see, there is a direct relationship between the amount of data stored in a table, the performance requirements, and the number of partitions allocated. When you go beyond 10 gig, or 3000 RCU, or 1000 WCU, whichever happens first, an extra partition is added and your data is automatically spread between the partitions for your table. So how is the data distributed between partitions? This is a very good question, and it's a very important concept to grasp, as it's massively important for the exam and managing performance in DynamoDB as a DevOps professional. When multiple partitions exist, the partition for a particular item is selected based on the partition key. For each unique partition key value, the item is assigned to a particular partition. Let's take an example of a table called test. It stores information related to students' test results for a particular test. Each test has a unique ID. If tests are repeated, for example, a regular math test, each test gets a new ID. You can have millions of tests, and each test may have thousands or even millions of students attending. And for each you store a result. Initially one partition may be enough, either because there are only a few tests and students or the performance requirement is low. But consider if the application which uses the table is needed to display national results in every school, millions of tests, millions of students. Then you will either hit the 10 gigabyte limit on data or the guaranteed performance limits. This is where partitions start being used and can improve performance. For example, DynamoDB may decide to scale out to 4 partitions as shown on the right. The system allocates each test ID, or rather a hash of the value, to a particular partition. A key point, a partition may host multiple partition key values, i.e. tests, but for each test, i.e. a single partition key value, there can only be one partition. Within each partition key, there may be many students taking the test, and this is an ideal sort key value. It will allow many items per partition key, so we can store the results of the one-to-many test-to-student relationship. But also, it allows sorting of the test results by the student ID, or the selection of test results for a particular group of students, i.e. a school. So you should start to have a real feel now for how DynamoDB handles capacity and performance scaling. By adding partitions or moving data between them, you can scale almost infinitely based on size or performance requirements of your data, but there are some serious limitations, and we'll discuss these and why they happen on the next slide. In the last slide, you learned about partitions, but it's worth adding a few key points regarding partitions. Firstly, the number of partitions is managed by DynamoDB and will grow automatically to accommodate performance or capacity requirements. While this is true for increases, there is no automatic decrease in partitions during capacity or performance reductions. And you may be wondering at this point why this matters, and this moves on to our next point. The allocated write and read capacity units are split between partitions, meaning if you allocated 30,000 read capacity units to your table, DynamoDB would create 10 partitions, each of which has 3,000 read capacity units. And this exposes a number of key performance and capacity characteristics of DynamoDB. We've explained that one partition can hold many partition keys, but that a partition key can only be held on one partition. This means that each single partition, i.e. in our example, each test, is limited to 10 gigabytes of data. And keep in mind that each test could have millions or tens of millions of students. Because each partition key is limited to one partition, which itself can only provide 3,000 RCU and 1,000 WCU, it inherits roughly those limits and is limited to those values. Keep this in mind when picking partition keys, and we'll talk about this more in the performance deep dive later in this lesson. But imagine a table for the US election where the partition key is a candidate and the sort key is a voter ID. You would quickly hit capacity and performance issues nationally using this data model, and we'll explain why in the deep dive section. Finally, be very careful when increasing write capacity and read capacity values. We've learned that when we increase either beyond the 3,000 or 1,000 for RCU and WCU respectively, one or more additional partitions are created. But when we reduce them, partitions aren't removed. And this can lead to a situation where we have a popular application during certain times of the year, which has hundreds of thousands of WCU and RCU and a substantial number of partitions. However, at off-peak times to save costs, we reduce these WCU and RCU values, but doing so doesn't reduce the number of partitions. We'll end up with a situation where each partition may have a tiny number of write and read capacity units, and we'll begin having performance issues even though the overall write and read levels are appropriate for the load. The amount, however, available to each partition key isn't, and we're throttled. In the example on the right, we think we have an overall write capacity and read capacity value of 100, when in fact it's split across 4 partitions, which inflicts performance restrictions on each value. So by now you should have a good understanding of DynamoDB partitions and how they influence not only initial DB and data structure design, but also they are critical in the long-term performance and operational management of your applications and data infrastructure. We'll spend more time deep diving the performance aspect of DynamoDB, but for the purposes of this lesson, there are a few key takeaways. An awareness of the underlying partition concept is critical. While at an associate level it's almost encouraged to ignore them, at a professional level you need to know they exist and to understand how they work. Be aware of the elements which influence the need for partitions and their automatic creation by DynamoDB, namely, each 10 gig of capacity creates a new partition, and for performance, every 3,000 RCU or 1,000 WCU causes the creation of a new partition. Understand that partitions can increase, but not decrease, and know that performance reservations applied at the table level are equally split between partitions. Know how this relates to the fact that partitions cannot decrease. Be very cautious in increasing WCU and RCU values and understand the impact. Know that true performance levels are based on allocated performance and key structure, together with the distribution of reads and writes across both time and key values. Don't worry if you have more questions than answers, just ensure that you understand the elements in this lesson. In a future one, we'll deep dive into DynamoDB and provide details on how to control and influence performance to a much greater level. Well, that's the end of this lecture, Cloud Gurus. Thanks for listening. If you have any questions, feel free to reach out directly or via the Cloud Guru forums. Otherwise, feel free to complete this lesson and move on to the next.